So we're going to be talking about solving linear equations. So let's see, what is a linear equation? It's an equation which basically has only x's. There's no x to the power of 2, no root of x, no 1 over x. So basically it's just simple x's. Yeah, basic. The reason it's called linear equation is because generally this represents a straight line. So y is equal to 3x plus 4 is a line. Y is equal to 2 is a line. Generally, all of this, it has a graphical representation, which is find where a line crosses the x-axis. But we won't be doing that. All we are going to be doing is we're going to be doing the algebra, not the graphical way. The graphical way is just a bit more complicated. But this is the other side of the coin, which is called graphical solutions and finding where the line crosses the axis. That's what we are doing, but we won't be seeing that. We'll just be seeing the algebraic side. So how do we do this? Well, all of these are equations. Basically, we want to solve them by moving everything to one side. Well, actually, everything which is not x on one side and keeping x on the other side. And we'll say x is equal to that. Like, for example, no, actually, I'm not going to do any examples here. I'm going to move on straight to the theory, which says, right, sometimes, because we are lazy in maths, the left-hand side, we write LHS. Keep that in mind to avoid spending seconds of your life in writing left-hand side. Same thing for right-hand side. So this is the LHS and this is the RHS. Saves a bit of time, right? So we basically have the left-hand side is equal to the right-hand side, and we are going to be doing things between these two sides to isolate x. Basically, let's look at an example. If you have something like 3x plus 7 is 13, what is the solution? It's 2. How do I know that? The textbook told me. How do I really know that? Well, if I replace x with 2, 3 times 2 is 6, plus the 7 here is equal to 13.
So always like we know the answer?
No.
We need to make like the x turn into a number, so it's like...
No, we don't always know the answer. In this case, you can see it because it's easy to see. So theoretically, you could solve it by inspection. This is what's called by inspection. Basically, you put in a value, it works. Oh, I solved it. That's it. It makes sense. So if you're in Inspector Gadget, you'll always be inspecting and finding the answer by inspection, but it doesn't always work. So if it doesn't work, let's move on to this so-called balancing method. So you imagine the equation as a scale, and the things you have on the left are equal to the things you have on the right. So if you take away something from both sides, this will still be balanced. If you add something to both sides, it will still be balanced. If you double the things on two sides, it will still be balanced. If you divide both sides, so basically you're allowed to add the same thing to both sides, take away the same thing, multiply by the same thing, divide by the same thing, raised to a power. So do the same thing to both sides. So effectively, if you have something like 2x plus 3 is equal to 8, you're allowed to take away 3 from both sides, because you're doing it to both sides. So if this is a scale, you take away 3 from both sides, you get a balance. So if you have 2x plus 3 is 8, you will take away the 3 from both sides, so you get 2x is 5. Why is this good? Because we can see what the value of x is here. 2 times what gives you 5? Sorry guys, yeah, this was really challenging, I know. 2 times 2.5. Okay, so x is 2.5. Sorry, I mixed it up.
I don't understand, like, on the first one, why the 2x plus 3 equals 8?
They just give you this. They give you this problem. For example, right? Imagine you've got 2x plus 3 is 8. You are okay. So imagine it graphically, right? So 2x will be the little blocks here. The 3 is the little orange thing is here. So if this is balanced with this 8 orange thing is here, and you take away, you will see, yeah, you're left with this and this. So this is like a graphical representation of what we're going to be doing. Now, this is the baby approach, okay? You're not babies. We'll just skip this stuff, guys. We'll just go and do the algebra, the proper algebra. I know. So basically, in this case, instead of doing it by inspection, because we've got Inspector Gadget in the classroom, he could always do that for us. But we can do it algebraically by taking away 7 from both sides.
And then you're left with 15, then so the x would be like 5.
Exactly, that's it. Thank you. Basically, we'll just divide both sides by 3 in the next step. and that will give us x is 5. So these are the really easy ones. So I do apologize in advance if your majesties find these too boring, because you might be already very good at this, but I want to show you the steps just in case. So this is the algebraic approach for this example. Let me show you another one. Now in this one, a lot of students will just collapse at the sight of this problem. So the problem here is the minus. So a lot of students will see a minus and go, oh, it's got a minus. How do we do it? Yeah, okay. I'll show you a couple of methods, I suppose. One would be to do minus 11 on both sides. That would work, yeah. So then you get, what is 11 minus 11? These two disappear. They're anti-heroes. It just gives you 0. And then you're left with minus 5x. So minus 5x on the left. Minus 5x. On the right, though, what is 26 minus 11? Quick maths. 15. Excellent. So we get 15 on the right-hand side. So notice we have minus 5x is equal to 15. So how do we solve? How do we keep x on its own? If you like, you can divide by 5. If you like, you can divide by minus 5. What do you prefer? 5. Okay, 5. 5 looks like a more normal number, right? Minus 5 is like so negative. Okay, so now if we divide both sides by 5, what do we get on the left? Well, the 5 and the 5, they will just be divided with each other, but the minus will stay there. So you get minus x, and then on the right, what's 15 divided by 5? 3. So minus x is 3. So what is x?
Minus 3.
Minus 3, exactly. So if minus x is 3, then the opposite will be minus 3. So x is minus 3. Now, if you find this a bit annoying, there is a second approach here. And the second
I don't understand. Can you explain again the first one?
Yes. This bit or the previous? So in this bit, if you have minus something is equal to this, if you like the mathematical, you can think of it logically as the opposite of the opposite, or you can think of it as multiplying both sides by minus 1. So if you multiply both sides by minus 1 here, minus x becomes plus x, because negative 1, so there's an invisible negative 1 here basically. Negative 1x times negative 1, it gives you positive 1x, because negative 1 times negative 1 is positive. So this becomes plus, but I don't put the plus there, it's invisible. So the opposite of minus x is positive x. I just multiplied this side by minus 1, and then I will do the same thing to the other side. 3 times minus 1 gives you minus 3. Does this part make sense? So what I'm trying to do as a goal is this. I want to keep x on its own. I want to end up with x is equal to something. So what is really annoying me here to start with is this plus 2. I just look at it, I'm like, you two, I'm going to move you to the other side. So how do we move this plus 2 to the other side? Well, what is the opposite of plus 2? Minus 2. So I'm going to do minus 2. But when I do it on one side, I have to do it to the other side. Because remember, we have a bit of a scale, right? Imagine this is the scale. I'm very bad at drawing, so do not laugh at me. Don't mock me. So there's a plate on the left, plate on the right, that sort of thing. So yes, this is a scale. So now we want to basically do the same thing to both sides. Okay, so we take away 2 from here, we take away 2 from here to keep it balanced. So what happens if we do that? Well, on the left, this positive 2 and the negative 2 will just kill each other. All right, it's called cancel each other, but I like the word kill. Okay, so 2 minus 2 will kill each other. So you're left with x over 3 is equal to, and what is minus 2 minus 2? High level maths. Minus 2 minus 2.
Negative 4.
Negative 4. Yes. Yes. 0 would be minus 2 plus 2. Yes. Or plus 2 minus 2. Okay, no worries. So now we are here. X over 3 is minus 4. Okay. How do we move this 3 to the other side? Minus. What is the opposite of x divided by 3? Times. So we need to do times 3 on both sides. So if we multiply by 3 on both sides, well, this divided by 3 we've got on the left will cancel with its anti-hero times 3. So when times 3 and minus 3 meet, this thing happens. and they just disappear without the sound.
27.
They don't even do that. This is my theory. So you're left with x, just x on the left, whereas on the right it's minus 4 times 3, which is minus 12. Menos 12. So basically, this is the final answer here. Now, if we go back and put this x is minus 12 into this, it will make sense, because minus 12 divided by 3 is minus 4, plus 2 is minus 2. So when students see this, generally they just sit back with a chair touching the desk of the person behind them. They just can't deal with this. They can't cope with the pressure. But I'm going to help you. How do you get rid of this fraction line with the 5 underneath?
I think it's
Exactly. Why? Because this means division. So fraction over 5 means divide by 5. So what we'll do is we'll do times 5 on both sides to eliminate this filthy fraction. Go back where you came from fraction. We don't like fractions when we solve equations because, well, basically they are hard for our brains to deal with. We don't deal with fractions very well. So what happens on the left? Since we have divide by 5 times 5, kill each other. They kill each other. Flap, flap. They die. And you're left with just 4x plus 3 on the left. Left with 4x plus 3. On the other side, though, minus 2 times 5. Minus 10. Yes. So that's equal to minus 10. And now we know how to do this. What do we need to move to the other side now? The 3. But it's plus 3. So what do we do to the plus 3 to get rid of it? Subtract 3, because it's the opposite of plus 3. So now if we do this, we get 4x plus 3 minus 3. Goodbye. And that's equal to... Minus. So we've got the following options. One answer is negative 7. Other one? Positive 13. Was that? Well, the lucky winner is... negative 13, yes. Whereas the other two, unfortunately, didn't win. Sorry, guys. So here it's a minus 13. Why? Because when you're at minus 10 and you take away another 3, you get to minus 13. It's like you imagine you're at minus 10 and you basically go 3 places to the left. That would be minus 13. So this is what minus 3 means. It means moving 3 places to the left. In any case, we got 4x is minus 13. So what would x be in this case? Well, how do we get rid of that 4x? What does it mean? Yes, exactly. Because there's a tiny invisible times here. I don't know if anyone can see it. Usually no one can see it. Can you see the times? Really? I can see it now as well. If we divide by 4, that's what will eliminate the multiplication. So elimination. So we get 4x divided by 4 gives you just x. Just 1x or x. And then on the other side, this is going to be very challenging, very tricky. Get ready for it. Minus 13 over 4. Certainly not 3.25, but it might be minus 3.25. Okay, so that is the final answer. Feel free to leave it as a fraction, guys. Fractions never hurt anyone, I think. So I'm going to stop recording here and I'm going to come back to answer questions.